Hey everyone, so today we're going to show you 3 secret DESMOS hacks that will help you get a 750 plus on the SAT math section. The first one is the scale graphing hack, okay? We have our question here. You're going to be using this feature on DESMOS when you're dealing with super big numbers like exponential functions, logarithms, a scientific notation as you can see here. So we have 2 populations of bacteria. Population A has that function, population B has that function, and the question wants us to figure out at what time t in hours are the populations equal approximately. So the first thing you should do here is pretty much just whip out DESMOS and graph these 2 functions and find where they intersect, right? The only problem with that is the conventional wisdom is when you do that, this is what you get, right? You graph the 2 functions, and then these functions are so big that you can scroll out as much as you want, but they're not going to show up on the current scale that you have, right? It's super frustrating that you can't just graph them. The only thing is you can just graph them. The only thing you have to do here is access a secret feature in DESMOS, and you can see this in the corner now is that little toolbar. Okay, so you're gonna hit that toolbar, and then down here, more options, you're gonna change the x-axis and the y-axis from linear to logarithmic, okay? What that's gonna do is pretty much just blow up the scale so you can deal with those big numbers. So now you can see our 2 functions actually show up with a much bigger scale, but we don't really care about that. We care about that intersection, right? So we have the intersection right here. We can see at 1.58-ish, and therefore that is going to be our answer for this first question, B. Moving on to our second hack. This is a new feature that DESMOS has recently added, so make sure you use this on the digital SAT, and that's the auto-regression hack, okay? So here's our question. We're given a table. We have 4 points, and we have a unknown point at f of 3. The question says the function f of x is modeled by a polynomial. It doesn't tell us what polynomial it is. That passes through all the given points. What is the value of f of 3? Now, typically these questions will tell you whether it's a quadratic, a cubic, if it's a polynomial function. It will specify, but in the rare case that it doesn't, then you really need to be able to use the auto-regression hack that I'm about to show you. So conventional wisdom goes, you do this, right? You've probably seen this if you have touched upon regression, which is doing that y1, the little squiggly sign, and then your regression model, and then DESMOS spits out all the info you need. But you can actually go through and skip all that by going to this little button, right? You put in your table with your values, and then in the corner here, you have this add regression button. You're going to click that. And what that's going to do is pop up the auto regression feature. Okay, here is where you're going to be able to select from a variety of options. You have quartic regression, quadratic regression, linear regression, logs, power rule, whatever. It's crazy. It literally does all the work for you, and it cuts that time in half. Okay, so for this question, all I went, because it didn't specify what polynomial it was, I just went through and tested out quadratic, cubic, and finally ended up with quartic because that's the only one where at x equals 3, where I got a value of 5.8-ish, that actually lined up with one of the answer choices. So C here is our answer. So the last DESMOS hack is going to save you so much time and so much headache, and that is going to be graphing stat functions. Question says here that we have a following set of numbers representing scores 0 to 100 of 13 students on a test. We have our set. If the median is 61, what is the smallest possible value of x? You can go in and sort this manually, least to greatest, and find the right value. But while I do all that, we can do this in like 10 seconds using DESMOS. You're going to do that by graphing it as a function. I know, that's crazy, right? So conventional wisdom goes is you can just type in median in the data set, right? It spits out a number, and that's cool and all, but what happens when you have a missing value in the set, right? Like this one right here, x. This was an actual question, like I'm pretty sure it was a question in a practice test in Blue Book. But besides the point, if we have this problem, we can graph it as f of x equals the median of that data set, and because it works as a function because we have x in it, right? And so here on the graph, what you'll see is that little jump. So that jump represents basically the x values or the values of the test scores that will yield a certain median. And so we can see that intersection here, we want the smallest possible value of x, and the smallest possible value of x here would be 61. Okay, it actually works out nicely. 61, 61 is the point at which the median jumps up, right? So if the score of the 13th student is a value of 61, that's the smallest possible value in which the median will also be 61. And therefore our answer for this is, answer for this is going to be 61. That does it for all the secret DESMOS hacks. If you want to review SAT math even more, make sure you click the full review with tons of practice problems, as well as our full English review. And yeah, best of luck on your SAT.